Hey, what's going on, guys? I just wanted to make a quick video over Unit 5 test review. Let's get started. I really hope this helps. Alrighty, let's look at number 1, man. We says for this polynomial right here, identify the leading coefficient, the degree, the end behavior, local maximum and minimum, the intervals of increase and decrease. Also describe the polynomial symmetry, okay? So first thing I want to do, man, is I'm going to go ahead and graph this thing. All right, so you want to put the equation in your calculator like so, then we're going to hit graph. And let this thing graph our function. I'm actually zoom in on this. Change my window specs for you guys. Alright, so I changed those window specs so we'll have a better view of our function. Alright, so now let's see here. Let's answer some questions. So this first one, what's the degree? The degree is 3. Alright, the leading coefficient is going to be 1. The domain, remember this is cubic. Our odd degrees have a domain of all real numbers, and it also has a range of all real numbers. Now, if you're watching this here from another class, you guys might do this, negative infinity to positive infinity. Alright, that is also acceptable as well as another answer. For domain and range, that means all real numbers as well. Let's sketch it real quick. Let me pick some points from the graph. If I go back over here to the calculator and second graph, we look at our table. We got some points right here we can use. All right, so there's some values we can use. So those values are, we had 0, -4. We had -2, 0. And we also had and 0, 4. So right here, there's one right there. Yeah, so we got something like this. Alright. So now end behavior. Alright, this means to the right, as that goes to the right plus infinity, which is out this way. To the right, the graph goes up. Because the graph goes up, we say positive infinity. And right here, as s goes to the left, negative infinity to the left, the graph goes down, so we say it goes to negative infinity. Now, maximum and minimums. Remember, we can use our calculator for that, our max and mins. All right, so what we're going to do is go back to our calculator. We're going to go second, trace. Let's do our maximum first since that's on the left. So there's the maximum, this hill right here. You're going to do left bound, right bound, and enter again for guess. All right, there's our maximum right there. So we have -3, 1.8, -3.8, and now 3.18, 2.59. There we go. Oh, that's our maximum. Hold on. And then we need to do our minimum. So second, trace. There we go. Right bound. There's our minimum. Bless you. So we have -1.15 7.57. There we go. So maximum and minimum. Now for our interval of increase and decrease. For your interval of increase and decrease, guys, here's what you do. There's our maximum, there's our minimum. Remember, there's negative infinity out here, positive infinity out here. I'm going to write the x values of my max and min. All right, I'm going to write those out. Now notice before you write them that the maximum came first. It's from left to right, the maximum came first. So I'm going to write the x value of the maximum first. Then I'm going to write my x value. All right. And then for your minimum x value is negative 1.15. So I'm just going to space it out right here, negative 1.15. All right. So now, all you do is this, from left to right. All right. From left to right, you read the graph like a book from left to right. So from left to right, I trace the line. See, this is going up. I just trace the line. I got to go up. So this is an increase. So I'm going to put the I right here in between these. And then from here to here is a decrease. See, I'm going down. That's a decrease. And then right here is going up. That's an increase. All right. So these are my intervals. Matter of fact, here, let me do that again for y'all, man. I really don't have to. You could just replay it, but trace the line, okay? Start from the left and just go to the right. Trace the line. I'm going up. So that's an increase. And then here, I'm going down. That's a decrease. And then from here, I'm going up. That's an increase. All right. Now, I'm done. I can write my interval of increase and decrease down. See how I have an I right here for increase? Well, that's my interval right there. I have an I for increase right here. I have an I for increase right here. So my interval of increase is going to be from negative infinity to negative 3.18. And then I'm going to have another increase from right here, negative 1.15. Oops. To positive infinity. Right? Now, when you look right here, and sorry to overlap this, man, but right here, see this is where the decrease is. You see the decrease, the D for decrease? All right, the decrease is from right here to right there, from there to there. So negative 3.18 to negative 1.15. All right, that's my decrease right there. Now, even, odd, or neither. Remember, symmetry. Even symmetry is symmetric over the y-axis. All right, it looks the exact same over the y-axis. Odd is symmetric about the origin. All right, and neither. In this case, this is neither. This is not, like if I rotate this 180 degrees, all right, it will not be the same image. So this is neither. Now it says use complete the square to write the function in vertex form. All right. So here we go. Define the vertex form. Remember, we're going to take this. We're going to add a space. And then we're also going to plus 12 minus a space. All right. X squared plus AX. All right. Plus 12, we just expand it to add a space and subtract a space. All right. And we're going to use this equation, right? B divided by 2 squared. All right. So now B is 8. So we have 8 divided by 2 squared. Well, 8 divided by 2 is 4. 4 squared is 16. So I'm going to go plus 16 and minus 16. So now factor this. Factor this because we're working to get vertex form. Well, when you factor this, all you have to do is look at that. That right there. You don't you can factor it. Two factors that multiply to give you 16 that add to give you 8. Of course, it's 4 and 4. All right, but 8 divided by 2 is 4. Well, that's it, guys. It's gonna be x plus 4 squared, and right here you simplify this. Negative 12 minus 4 will be negative 4. All right, this is vertex form. All right. So now, is there a max or min? Well, we need to graph it. Let's graph it now, okay? All right. So graph. We got a quadratic. All right. So there's our graph. I'm going to sketch the graph real quick. So let me sketch it. So we have 1. All right. Negative 2. Oops, wrong thing. Right here. Negative 2. And 3, 4, 5, 6. All right, negative 6. All right, and then, well, here. All right, so we see those those roots right there. All right. Is there a maximum or minimum, guys? There's a minimum. All right, there is a minimum. Matter of fact, here, I don't even have to write that out and circle it. There's a minimum right here. All right, it says what is the value of the max and min? All right, remember, now that we have a vertex form, guys, we can just solve it. Remember right here, x plus 4 equals 0. So h is going to be negative 4, and k is negative 4. So the vertex, all right, the vertex is negative 4, negative 4. All right, there's the vertex. So negative 4 right there, okay? So now, let me graph this thing right here. What's my y-intercept up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up here, so I'm going up here. Factor form. Factor form means we need to factor this. All right. So again, 2 factors that multiply to give me 12, that add to give me 8 is going to be x plus 6, x plus 2. All right. 6 times 2 is 12. 6 plus 2 is 8. So now we got to find the roots and zeros. Well, if I take both of those, set them equal to 0. All right, I get negative 6, and x plus 2, I get negative 2. So x equals negative 6, negative 2. All right. Now in behavior, as x goes to the right, notice the graph goes up, so it's positive infinity. And x goes to the left, it goes up, so positive infinity. That's in behavior, okay? All right, now let's look at this graph. First of all, it says identify whether the function graph has odd or even degree. Has an odd or even degree. Well, guys, see how the endpoints are in different directions? That tells us that it has an odd degree. Odd degree functions end in different directions. Remember, even degree has endpoints in the same direction. Now it says a positive or negative leading coefficient. We look at the right side. See the right side? The right side is going down. That means that we have a negative leading coefficient. All right. Now, with this problem right here, the direction says use the degree and end behavior to match each polynomial graph to its function. So for this one, let's go ahead and look at this graph. Let's look at some things. With this graph, both ends are in the same direction, and the right. So because both ends are in the same direction, that means that it has an even degree. All right, even degree. That's not every day. I don't want to confuse it. We'll say even degree. All right, and then see to the right, it goes up. That means it has a positive leading coefficient. All right, positive leading coefficient. if you look at this function, to the ends are in different directions. So that means it is an odd degree. And see, to the right side goes up. So that means it has a positive leading coefficient. Right here, the ends go in the same direction. So that means it has an even degree. All right. But see, the right side goes down. That means it has a negative leading coefficient. And right here, they go in different directions. The ends do. So that means it's an odd degree. But the right side goes down. So that means there's a negative leading coefficient. So now let's use this information to match the graphs. Okay. This one has a positive leading coefficient, but an odd degree. So positive leading coefficient, odd degree. All right, that's going to be B. For number 5, we have a negative leading coefficient with an odd degree. All right, negative leading coefficient, odd degree. So this is number 5. This is 5th degree. I wrote 5. Sorry about that. This is D. This one has a positive leading coefficient. All right, 1, positive 1. And then it has an even degree. So that's A. And then this one has a negative leading coefficient with an even degree. All right, and that's going to be C. All right. Now, lastly, we have this number 8 right here. It says create a table of values for the function and graph it. All right, here's our function. And you really, man, can graph this. All right, you can use your table for values on your calculator, and then you can sketch your graph. So let's go ahead and do that. We have negative x squared minus 4x plus 4. So, all right, so let's say graph. Okay. So now, man, let's see if our table gives us any information. All right, it does. All right, it does. All right, there's some things right here that we can actually see on our graph and put in here. All right, so let's see what we got here. We can graph let's see, 2, negative 8. And the reason I'm working down from up is just, it doesn't matter. You can put it in however you want, but make sure they're in order. All right, 0, 4. Negative 1, 7. Negative 2, 8. Negative 3, 7. Negative 4, 4. All right, so I'm going to put those on the graph. All right, so again, negative 4, 4. All right, we have negative 3, 7. We have negative 5, 1. Negative 6, negative 8. Negative 6. Negative 8. Again, man, I'm just getting all these from the graph. Let's see here. I did negative 3, negative 2, 8. Negative 1, 7. 0, 4. And 1, negative 1. Negative 5, negative 1. Oh, I got one in the wrong spot, guys. There we go. Negative 5, negative 1. There we go. Alright, I had to check myself right there. 2, negative 8. 2, negative 8. Alright, so anyway, there we go, man. Let's go ahead and connect this. Sorry guys, if there we go. I know it's not perfect, but there's your parabola, guys. All right. I wish it looked like this, but I'm not that great of an artist by hand. Now, state the domain and range. Well, the domain, guys, the domain for quadratics, all right, these quadratics, man, it's all real numbers. All right. Quadratic, guys, all real numbers. No problem there. All right. Now, for the range, guys, this is the maximum right here. All right, that max, guys, that maximum is this point right here. -6, -8. I mean, excuse me, -2. -2, -8. That's our maximum right there. All right, -2, 8. So now that we know our maximum, notice how the graph goes down from here. All right. See the y value? Everything's getting smaller. 8, 7, 6, 5, 4, 3, 2, 1. Like, see how this is going down? You know what I mean? So the y values are getting lower. All right, they're getting lower. Okay. So a couple different ways to write your range. Either you can just say y is less than or equal to 8, or you can say from what I put -8 right there. Sorry about that. 8. Sorry, so sorry. Or you can go 8, or let's say this, -infinity to 8. All right. You can say it like this or like this, guys. All right. Most of my students are going to do this. All right. If you're from another class, you might say something else. But y is less than 8, guys, is your range. From 8, it just goes down from there. So y is less than 8. Remember, range is your y value. The domain are your x values. So that right there isn't affected, all right, in terms of the range. But the y's get smaller from there, okay? But, hey, that's it. Listen, I really hope this helps. And good luck on your test tomorrow. Catch you later.